Now let's look at another important concept in C++ classes, that is this pointer. Whenever we call a member function for an object, C++ automatically passes a hidden pointer to that object into the function. That hidden pointer is called this. So inside any member function, this pointer always points to the object that invoked that function. Let's look at this simple example. Here we have a class named where, and inside it a function named reveal prints the value of this pointer. So in main function we create an object w and prints its address using ampersand w. So when we called w.reveal, it prints the address stored in this. Now when you run this program, you will notice something very interesting, that is both addresses printed are exactly the same. That's because inside the reveal function, this is literally pointing to the same memory location as the object w in the main function. So we can say that inside any member function, this is a pointer to the current object, that is the one that call the function. So this pointer is extremely useful when we want to refer explicitly to the current object, to its current instance. And now that we know that what this pointer is, that is a pointer that refers to the current object, let's see how we can actually use it to access objects' contents. Remember, this is a pointer, and pointers do not hold values directly. They hold addresses of memory locations. So if we want to access the data members of the object that this is pointing to, we first need to dereference it just like any other pointer. That is done using a static operator. So when we write static this, we are saying go to the object that this pointer refers to. Let's see that in code. Here inside the reveal function we are printing static this dot v. That means take the object pointed to by this pointer, then access its member v. Now even though v here is uninitialized in this example, the focus is on understanding the mechanism. So this gives the address of current object and static this refers to the object itself. So inside the function, static this dot v means v that belongs to the object that called this function. We have already learned that this pointer refers to the current object, and by dereferencing it we can access the object's data. Now let's take it one step further and see that there are other two equivalent ways to access a member variable through this. So inside the reveal function we are printing the same member variable v in two different ways. The first statement uses static this dot v, which means take the object pointed to by this, then access its member v. And this second statement uses this and again this sign, which is just a shorter and cleaner way of writing the same thing. So these both are equivalent ways, both access the same data member of the current object. Now in practice, most programmers prefer using the arrow notation because it is easier to read and avoid extra parentheses. But conceptually it is good to remember that under the hood both forms the same thing. So when you see arrow operation member name, think of it as a convenient shorthand for static this dot member name. So both are valid and both rely on the fact that this is a pointer to the current object. Sometimes we use parameter names in our functions that are the same as our class data members. When that happens, the local parameter hides the member variable, and this is called naming collision. To resolve this, we use this pointer to clearly refer to the class member. For example, if both the member and parameter are named value, we write arrow operator value is equals to value. So the one on the left refers to the data member and the one on the right is a parameter. So this makes the code unambiguous and ensures that we are updating the object's actual data member. Now let's look at another powerful use of this pointer, the cascading function calls, also called method chaining. Sometimes we want to call multiple member functions on the same object in a single line, like obj.setx5.setxy and maybe many other calls in a single line. So this style makes the code shorter, cleaner, and you can say more expressive. To make that possible, our functions must return the current object itself, and that is exactly what this pointer allows us to do. So in this example, set x and set y both return static this, which refers to the current object, that allows us to chain the next function call right after the previous one. When we write p dot set x 5, so the first call set x returns the object itself, which then calls set y, and finally the show function. So this technique is widely used in modern C++, especially in the stream operations and fluent APIs to make the code more expressive and readable. Here's another example that demonstrates how cascading function call work, but this time using this pointer directly. So in this program we have a class called demo with 3 member functions, fun1, fun2 and fun3. Each of these functions print a message and then returns a pointer to the current object. Now look at the main function. When we create an object named ob and then call ob.fun1, then arrow operator, then fun2, then arrow operator, and then fun3. So let's break down the statement and see how it executes step by step. First, ob.fun1 is called, and inside fun1 we print fun1 called and then return this, which is the pointer to the same object ob. Now the return pointer this immediately calls the next function in the chain, that is fun2. So inside fun2 again a message is printed, fun2 called, and the same this pointer is returned, still pointing to ob. Finally, using that return pointer we call fun3, which prints fun3 called. In the previous example we saw how cascading function calls work when each function returns a pointer, specifically this pointer. Now let's look at a variation of an idea where each function returns the object itself, not the pointer. Here in the class demo we have 3 functions, again fun1, fun2, fun3. Each function prints a message to indicate that it is being called and then returns static this. So now this time it means it returns the current object by value. Notice the return type of each function, and this time it is demo, not demo static. It means each call produces a copy of object rather than returning a pointer. When we call ob.fun1, the following happens step by step. So the first step is fun1 is called on ob object. Secondly, the message fun1 called is displayed, and finally fun1 returns a copy of this object, that is a temporary object created from static this. Then on that temporary object fun2 is called. Again message is printed and it returns another copy, another temporary object. And finally fun3 is called on that second temporary object, and then we see a relevant print message, that is fun3 called. So we can use this pointer to avoid naming collisions. As in the function you can see that if we write r is equals to r, then this is ambiguous statement. So we can use this pointer to avoid naming collisions, like this arrow operator is equals to r or static this dot r is equals to r.